So I'm going to continue the love fest for the lower trophic level in our food web work. I want to thank Ann Cotter and Matt Pulaski and John Lonsbach for work on this over the past few years. What I'm talking today about, very briefly, is a tool, a means to an end, and one of those ends you just saw, which is the EcoPath EcoSim food web. And so hopefully I'll illustrate in the next 5 minutes exactly what I mean by an opportunity and a means to an end. So what is an isoscape? An isoscape simply is a systematic variation in light isotopes across a very large spatial scale. I've shown you an example here on the right for North America. This is actually the light hydrogen isoscape across North America based on dragonfly wings. Ornithologists actually use this to understand movement and diet of birds across the North American landscape. And we had a thought going back now to the late 2000s that maybe we could do something similar in Lake Superior. That would give us new insights into the spatial structure of the food web, maybe a little bit about what's going on at the bottom in terms of that lower trophic dynamics, the algobiogeochemistry, the microbes, a little bit more insight into the food web dynamics. And we also thought if we could express this at depth, we could do a little better job with that big bulk of water that we often call the pelagic zone, which all of us recognize is actually multiple zones of production, and how those multiple zones of production really matter in the Great Lakes. They matter here because we know it's not homogeneous. We have this deep chlorophyll layer that has a special role. And it matters a lot with respect to the other Great Lakes, where we're seeing tremendous changes in the upper food web dynamics because of the dry-setted mussel invasion. And so some insight here in Lake Superior could certainly inform some of the changes going on in the lower lakes. And so using the advantage we have from the whole lake sampling design from both 2006 and 2011, we used the opportunity to put together this map. Let me show you what that map looks like. This is an isoscape of Lake Superior. This is for carbon, delta 13C, so this is the 13C to 12C ratio. This is in particular organic matter collected from the water column. It's collected from the epilumnion from 3 different depths. We composite it equal volumes. We analyze the particulates across it, and I want to make a couple points. First of all, we traditionally thought of this as a fairly homogeneous, from a biogeochemical perspective, kind of everything's around a value of minus 26. Don't get your mind wrapped around the value right now. We saw surprisingly more variation than that, about minus 23 to almost minus 28, far more than we were expecting. We also saw patterns. We saw enrichment in certain areas, and interestingly, we saw this huge feature show up in the middle, which looks a lot like the Eastern Gyre. It looks a lot like the Eastern Gyre, whether you measure it by currents or whether you measure it by temperature. And so there seemed to be some also indication that the physical limnology of the lake is actually structuring that. And we thought that was really interesting. That might provide some long-term opportunity to do work. But we had to go back and do it again. So there's example our map, those maps. I think your eye can pick up the similarities. But that was 2011, and we thought we should go back and look at it again, just to make sure this is a repeatable result. And so we did it again in 2016. The 2016 map is on the right, the 2011 one I showed you. And you can see there are actually quite a bit of spatial coherence between the two. In fact, if we ask, are they correlated? The answer is they're significantly correlated, with not a huge amount of variation explained, but actually substantial, given that we're talking about particles in the water column over a tremendously sized lake, giving us hope that the spatial coherence can be mapped over multiple years and actually used to begin picking apart the food web in space. Interestingly, in both years, we also looked at its difference in depth. So these are the frequency distributions of the epilumnion in black versus the DCL, or the fluorescence max, in gray. And in both years, you can see that the epilumnion is shifted upward and the F max is shifted downward. In other words, we're seeing a discrete difference. Most importantly, the difference, the magnitude, is actually shifted to where it's actually more depleted at depth. That's an interesting point, because if it was just bacteria driving this, it would actually probably be enriched. So the fact that suggests this is an independent zone of production that we can pick up isotopically and begin to partition the water column into different feeding components. So that big black box of pelagic suggests we can actually break that out and have some insight that's particularly important for the food web modeling. So what we're seeing in these 2 years, I think, is some really compelling evidence that we have some consistent patterns, both with space and time, and that it extends into the depth. We get a correlation among years, suggesting that this is something we can come back to year after year to do studies with. That trophic ecology here offers an opportunity for supporting this sort of spatial and depth-specific food web research, which we've not been able to do in great detail to date. It also includes opportunities to look at how fish are moving around the lake. So I just told you new ways to measure how the Lake Superior food web is changing, especially as it relates to these spatial differences and depth-specific. I think one opportunity here for us for the next CSMI is to actually do this kind of work, very fine-scale, depth-specific work at a few select spatial locations and tease it apart. This kind of information would be highly valuable, I propose, for the EcoSim with EcoPath model. It offers an opportunity to look at climate change over time because of the important role of the DCL in thermal stratification, and also better ways to look at how contaminants bioaccumulate in the food web. And I'll reference Ryan's talk later today. Thank you.